you're making, when you're doing this in EF6, of course, and you'll say something like, my property, ooh, my property, and then React prop types. I think this is how that works, string. It might actually be lowercase p. Let me just check that out quickly. Let me just check that out. React prop types. I can't remember the exact capitalization of that. It is capital P. Okay, that's cool. So you can define things in here that will validate the properties that you put into a component when you call it. And that's a good question. Simulated Greg asked a good question. I'll ask it again and get to it when we do this code. Actually, maybe now's a good time. Maybe now's a good time. Thanks for asking that. So Simulated Greg asks, what does React aim to accomplish? It's kind of a loaded question. It's kind of a loaded question. I think the way that I'd like to answer that is that when you're making interface things, when you're designing a big application with a complex hierarchy of components in your interface, things get kind of messy. Say you're making an e-commerce site. I'll put this back to talking. Yes. Say you're making an e-commerce site, and you've got a list of products that are in your e-commerce site, and maybe like a shopping cart in the top right, and you want to have Ajax power a lot of that stuff so that you don't do full page refreshes the whole time, or so that the interface can feel a bit more responsive. Then you would probably do something like add event handlers to buy buttons next to products. And when those are clicked, you would tie into the shopping cart. So you would get the shopping cart with jQuery or whatever you're using and add elements to it or change text in it so that other parts of the site can respond nicely to events that happen elsewhere, to significant events. And that's what gets kind of messy with it. You end up coupling large parts of your site together without necessarily meaning to, and when you need to change things, this is kind of an inflexible approach. You have to worry about all kinds of events happening all over the place and making sure that all the edge cases of your interface work nicely together. And there have been a lot of libraries and architectures to try and get around this. And they usually take the form of splitting out different, let's call them technologies. So they'll do things like have templates as like a string or like an element with HTML inside. And they'll have models or data objects or something to that effect that synchronize with a kind of local storage or database or backend or over sockets or whatever. And then they'll have controller stuff that sits in the middle, like a kind of glue, tying parts of the templates to parts of the data model. And they sometimes listen back and forth in a process that's called two-way binding, or two-way data binding. And so this kind of gets to the point where things happen consistently, but it's very complex to do this kind of stuff. If you've ever spent time doing a big project in Angular or Ember, you may have at some point felt a little confused, and I don't blame you, because those things, big libraries like this, can be very complex to get. They can be very difficult to keep in mind and to remember all of the conventions that you need to use to get things to work in a predictable way. React goes in a completely different direction. It says, imagine your interface in individual units. What would those units look like at any point in time? Can you describe what the markup would be like given any state, any kind of conditions? What would that component look like? So think again of your product list. What would your product list look like if it had no products in? What would it look like if it had 10 products in? What would happen if you clicked a button on the product list? How must the product list change? Okay. Then think about the shopping cart. What does that look like when there's something in, when there's nothing in, when someone clicks checkout? What are all those things going on? Okay. But just think about them in terms of the individual component. I've lost chat again. Now, okay, so what do they look like in terms of individual components? Then React outlines, not React specifically, but Facebook have a set of guides for how to structure larger applications in this, in a framework called Flux. And I won't talk much about it, but what they're doing is they're saying, okay, given that you're just thinking about your interface in terms of individual elements, self-contained, how do they interact? Do you start emitting events from inside components far down a hierarchy? Do you have one major parent component that does all communication? Do you have one data store that is responsible for getting and setting data that's reflected in your UI? Or do you have many data stores? And it's kind of taking things from a very different point of view, because instead of separating out technologies and having templates and having data objects and the controller glue in between and all these kinds of complex things attached to that to get that to work, like scopes in Angular, or associations of component names in controllers and views for Ember, for instance. Instead of those complexities, it says, okay, worry just about the component and write markup for what it's supposed to look like within that component, and even style it in line. Because yes, you can separate these things out and you can have separate style sheets, and there are pros and cons to that approach, and you can have separate markup and JavaScript that controls it, but actually the stuff is all combined. It's not markup and logic, it's markup and logic that controls what the markup looks like. Those are fundamentally linked. And so React says, okay, do it all together, and then just think about sensible ways of connecting it together. Hopefully that description did it justice. But as we go along, feel free to ask questions about the stuff, and I'll try and answer it sensibly. And if you hear me say something that you disagree with, question it, because we can get to the bottom of these kinds of things. And I don't know, let's have fun. Back to coding. Now, we can create a simple component like this. I haven't really outlined this kind of syntax. If you've come from... Yes, Simulated Greg brings up a good point. It's often called the V in MVC. The creators of React just call it like a view generation library. It's all about the appearance of a component at any amount of time. React doesn't come with concepts of database storage or local storage or routing. There are things that libraries you can plug into and download for that, but React's just concerned with how things look, and they do it very cleverly. Now, this syntax is kind of common if you've grown up in a language that does like Java or C# or PHP, where you have things called classes, and classes are like blueprints. They're like types. Like you can think of a string as a type. There are certain methods you can call on it. There are certain properties it can have, like length, and classes are like that. They're like a userland implementable type. So it's possible in the latest version of JavaScript that's kind of been rolling out in browsers these days to do classes, to define classes. And these are little more than functions that have kind of a greater scope. So it's functions to which you can attach other methods and properties, but ES6 exposes a little bit of syntactic stuff to make using the class keyword possible, and it just does all the stuff behind the scenes to simulate classes. It's not a typical class-based inheritance system like PHP or like C# or like Java. It's prototypical inheritance, which means, and because it's possible in a dynamic language, it means that you can create a type in JavaScript, and you can create other types based on the behaviors of that first type. You can create, in similar terms, a class and a subclass. But you can further modify the parent. You can modify the original type. And instances of the subclasses or the subtypes will inherit that modification unless they've overridden it. It's super interesting. If you're familiar with Ruby, it's possible to do something similar like that in Ruby called monkey patching. At least the way that you use it can be similar. It's not the same mechanic, but the way that you use it can be similar. So using the latest version of JavaScript and React, we can create components like this, which are subtypes of a React component. all that is to say, this will work like classes that you'll be familiar with. Super is an alias to the name of the parent type. And so if you wanted to do something, if you wanted to call a different method on the parent class, you could say something like super method with the parameters. Super just refers to the constructor of the parent. I should have said that first. Anyway, what this is going to do is we're creating a subtype or a subcomponent of the main React component. We've kind of got this as a placeholder if we want to do some constructor stuff. And every React component has a render method. And you can think of this render method as being the method that determines what markup that component does. You can imagine it's just getting called once. But you can do some state-based stuff. So you can say something like, if this props color is red, for instance, then you can render something like, you know, you just render other elements, else render a default, whatever. You can do logic here that changes how this component's markup is rendered. And you can imagine that it's only getting called once. In actuality, it's getting called as many times as the data given to this component changes. But you don't have to think about that, at least not when you're beginning anyway. Now there's a funny kind of markup here, and it's a div. It looks like HTML within JavaScript. React has this superset language, an optional superset language. You don't have to use this, but it's an optional language called JSX. And what it is, well, I don't actually know what that stands for, but how I can describe it is that you can mix markup inside JavaScript, and it just gets passed to ordinary JavaScript, ES5 compatible JavaScript. There are a few edge cases which we will explore as we use React more and more, but this kind of thing, it looks weird, but it's okay. And it's along that line of thought that you don't need to be separating markup and logic that controls that markup. You can put it together because, yes, that's what JSX is. You can put it together because it's all part of the same component, and it's an interesting, novel way of thinking about what this looks like. Now here I've done prop types here. You may be interested to know how this actually gets used. If we go to something like index and we remove, and we just have my component in here to match the name of this thing, my component, I'll show you how that gets referenced now. I just need to rename this class again because it's wrong. My component, and that stuff all exports. Okay, so if we do something like my component here, we can render new my component. That's interesting. I'm also going to put this in document.body because that's all I want to do. And then how we reference this is that we have to create a kind of map to these files. We wouldn't have to do this if we had a build chain that combined these files programmatically. Also, I want to change this to be just a little bit more consistent with the other stuff that we've got going on. We just have to create this reference now because of the code that's going to load the stuff automatically for us. You don't need to do this if you're not doing live. It's a kind of live interpretation. You don't actually need to do that if you've got a build script, a build process that will convert this to ES5 compatible code. Okay. I copied the wrong thing there. Got some really funny syntax. Oh no, what has it done? It's done some really interesting stuff. This is why you make sure you don't copy and paste dodgy code. Move to trash. My component. Okay, so this should be a JavaScript file now. The parts that are ES6 are this kind of importing, this kind of class stuff, the way that these methods are defined, and exporting this component. And we export this component for the same reason that we can import an object from this reference, because the default thing that's imported is